So for these, the difference with today is your theta, these ones today, your theta is either going to be 0, 90, 180, 270, or 360. So these are going to be on the axes, on the XY axes. So we won't be using special right triangles today. We'll just be using coordinates. So today is a little bit easier than before. So if we're talking negative 270, you've got your, let's make an XY axis here. And counting purposes, if you have trouble remembering which is negative, down is negative. So if you're doing that, then this will be negative 90 and then negative 270 and negative 360. If you think of the positive way, positive on the y-axis is up here. So this would be the positive 90. The 180s are the same. Okay, so if you have trouble remembering which one goes where, this is negative on the y-axis, so you start negative here. This is positive on the y-axis, so you would start counting positively there. Okay, so if we're talking negative 270, that is right here, right on the axes, right on the y-axis. And that coordinate on the unit circle is going to be 0, 1. So this stuff over here is the really important stuff for today's lesson. So what you need to know is if you're looking for sine, sine is usually your y value. Remember yesterday we talked about cosine was your x value and sine was your y value when you're doing the unit circle. So cosine gets the x and the sine gets the y. Okay, so when we're looking over here, we want, since we're looking for sine, we're looking for the y value. And if you notice that the y is over r, radius is 1. This is a unit circle. So you don't have to really think of it as putting it over r. Just think of it as putting it over 1. Okay, so you're going to get 3 different types of answers. You're either going to get 1, like this one, because this is y value, which is 1 over 1. So you're either going to get an answer like 1, or if we did cosine of negative 270, if you did the cosine, you would use the x value. So you would have 0 over 1, which would have been 0. Okay, so you're either going to get 1, you're going to get 0, or if you get, like for tangent, if you do y over x, if they did tangent of negative 270, then it would have been y, which is 1, over x, which is 0. And if you have 1 over 0, then that's going to be undefined. So if they're right on one of the axes, you're either going to get 1, 0, or undefined. You can't really show your work on this, but I want you to show me which coordinate you used. So this one I used 0, 1. Okay? Tangent, we have 3 pi, so I have to change that. Some of you guys might understand and be able to tell where 3 pi is, because I told you that this was 2 pi. So 3 pi is going to be at 180. If you can't understand how I just did that or how I did it in my head, then don't worry, just convert. So 180 over pi, so that the pi's go away, and 3 times 180 is 540. So 540, we don't really understand in the degrees, so just subtract 360, continue to subtract 360 until you get a number that you understand. So if it's a really big number, like 900 or something, just keep subtracting 360 until you get one that you recognize. So if you subtract that, you're going to get 180. So for this one, we're talking 180, which is going to be negative 10 on the unit circle. So we're talking tangent, which means I'm going to need both of these. Okay, so tangent, you have to put y over x. You have to put sine over cosine. So y is 0 over negative 1, and 0 over anything is 0. So you'll never get an undefined for sine and cosine, but you can get an undefined for anything else, because if your x's and y's can be your 0 values. So if you get secant or cosecant, there's a possibility it could be undefined, and tangent and cotangent can also have the possibility of being undefined, but never sine and cosine because they're always over 1. Okay, and secant. So 11 pi over 2. We can convert. You want pi to go away, so pi goes on the bottom. 180 divided by 2 is going to give you 90, and let's do whatever 90 times 11 is. So 90 times 11 is 990. So let's keep subtracting. Where's my subtracting? Keep subtracting 360. So it's still not a normal number, so I'm going to subtract 360 again. There's a normal number that I recognize in a circle. So I'm at a positive 270. So that's down here. So positive 270 is going to be 0, negative 1. And if I'm looking at secant, keep in mind that secant, the s's don't go together. So s goes with c. So that's the inverse of cosine. So remember that cosine uses your x value. So for this, for cosine, it would normally be 0 over 1 because it's x over 1. So if it's secant, I have to flip it. And if you're going to have 1 over 0, can't have 0 at the bottom of a fraction. So this is your undefined. So that's kind of an example of each that you'll see. So when you do this, just tell me which coordinate you're using. That's all the work you can really show for these ones. That way I know you're not just sticking it in the calculator, but you can't really put secant, cosecant, and cotangent in there anyway. Okay? So down here, I was just showing for each of these. So if you had theta as 0 or 180 or 90 or 270, remember the 0 and 360 are the same thing. So this covers everything. So if you're doing 0, that's this one in green. So they kind of color code it. So if you're doing cosine, cosine is your x value, which is 1. So it would be 1 over 1. Because cosine is over radius. So cosine is x over radius, and the radius is always 1. Sine is y over radius, and the radius is always 1. And tangent is y over x, because it's sine over cosine. Okay? So if you do sine, sine of this is going to be 0 over 1, which is 0. And if you did tangent, tangent would be what? 0 over 1. Okay, and then you can just flip them for secant, cosecant, and cotangent. It's the same idea. Okay, so if you have 90, you're using the blue one over here. So for the blue one, if I do cosine of 90 or pi over 2, whatever, if I do that, I've got 0 over 1. If I do sine, that's 1 over 1. And if I did tangent, tangent is y over x. So tangent of 90 would be undefined. Okay, if I did the 180s, 180s are in purple. So 180s use this purple dot over here. So if I'm looking for cosine of pi or cosine of 180, I've got negative 1 over 1. If I did sine, I've got to use your y value, which is 0 over 1. And if I did tangent of pi or tangent of 180, that's going to be y over x, so 0 over 1. Okay, and then in red, I've got the 270 in red right here. If I do the cosine, that's 0 over 1. Sine would be the negative 1 over 1. And if I did tangent of 3 pi over 2 or 270, then I would get negative 1 over 0, which is undefined. Okay, and then you guys can do the rest, the secant, cosecant, and cotangent. You just find those ones. As long as you can find the 3 of these, all you got to do is flip it for the other ones. So that's all we're working on today. On your worksheet, though, I might have thrown 1 or 2 in there like yesterday, just for a little extra practice. So if you get one like yesterday, make sure you show your reference triangle. Other than that, all you really need to do is show me what coordinate you're using for these. Okay, so today's a little easier, much shorter. Good luck.